What they call an other type of equation, also known as a radical equation, because it has an exponent that is a fraction. So look at this beast. It's something in parentheses raised to the 3/4 power. A scary question. How many of you noticed on the inside of the parentheses you had a quadratic equation? But everything got screwed up when we did the fraction or rational exponent. Now, if I asked you what makes this question hard, you're going to say, well, obviously it's that exponent. That's what messes it up. And so you learned in class, well, you can raise something to its reciprocal power and remove it. But the hard part, which I want to share with you, is when you raise something to a power, you have to raise everything to a power. And more importantly, you have to raise both sides to a power. When I say sides, you see that equal sign? That means you need to raise this side to a power, and you need to raise this side to a power. So one of the secrets, really quick, is you need to move the -2 over, or this question becomes a form of hell. I'll show you what most people did. Most people said, let's raise it to the 4/3, 4/3, and 4/3. And I was proud of them, because at least you said, well, I did everything to every piece, Dr. B. But in this case, that's totally wrong. Because I told you, everything gets screwed up when you have pluses or minuses between terms. You just can't do that stuff. If you were to do it accurately, you'd have to raise the entire side to the 4/3 and this entire side to the 4/3. That's accurate, but what does it introduce? A middle term. Do you agree when you do the raise to a power, it introduces middle terms? So that sucks also. So yeah, for the people who missed this question, man, it was fraught with terror. What do we have to do? First step. I'm going to tell you, the first step is always to isolate the thing that is a rational exponent or a radical. You get it by itself. So I'm going to move the -2 over, and we end up getting this. X squared minus x minus 4, this whole expression, raised to the 3/4 power equals 8. The 6 plus 2 gives you your 8. Now it's safe. Now it's safe to raise things to the reciprocal power. Now it's safe. Because this thing is kind of like one object being raised to a power. This is one object being raised to a power. It's easier to see that side. Now what happens when you have a reciprocal power, power raised to a power? You multiply, Danielle, but you multiply, we don't die, we multiply. It cancels out. The left side becomes a very beautiful, even sexy quadratic. This actually hurt a lot of students. 8 to the 4/3 power, they're like, whoa. They tried to multiply it and said it's 32/3, that scared me. This is raising to a power. That's different than multiplying. You go to your calculator, and a lot of calculators have this button, or an x to the y, but you raise this to a power, and when you do it, it comes out to 16. So this is a calculator answer. Not expecting you to do all the work. You could do it by raising things to outside, top, using the radical form, but I'm not asking you to do that. Just get your calculator to get 16. Now, look at what you started with, the beast. Now you just have a quadratic equation. And what's the secret to quadratic equations? Set it equal to 0. So this 16 I'm going to subtract from both sides. And you end up getting x squared minus x minus 20 equals 0. This equation is equivalent to that equation. Which one do you like more? I hope you say this one. But you had to do all that work. You had to use all those rules of algebra to get here. Now we are just solving a quadratic equation. And I always told you, easiest way, if it's workable, is by factoring, right? So is there something that multiplies to give you -20 and adds up to -1? I know you're going to say, how about -5? And how about x plus 4? You have these two factors. It turns out you set the factors equal to 0. Set the factors equal to 0 by the zero product property. X equals 5 is one answer, and x equals -4 is the other. And because you're raising it to a non-even power, both of those answers work. They're not extraneous solutions. Both of these answers work. You can plug them in and find out. So good job. That's how you handle those beasts.